In this video, we're going to do some of the, hopefully demonstrate some of the intricacies of analog EQing, and we're going to see how tough this really is. So I'm going to show you my setup here. I've got my frequency counter that's generating a sine wave at 1 kilohertz, and just to make double sure that that's actually 1 kilohertz, I've got my frequency counter here with a gate of 0.1 second, so that's measuring the frequency 10 times a second. As you can see, it doesn't get much closer than that. That's pretty much bang on 1 kilohertz, so no problems there. And just if you don't know what we're going to try and do in this experiment is we're going to try and see how sensitive this EQ section really is, and you know, turning these knobs here in the EQ section, we're going to see if we can boost or cut 1 kilohertz, and there's a pretty clean signal here. There's not a whole lot of harmonics happening with this guy, so we should be able to pinpoint this fairly accurately and suck it out or beef it up. But again, we're going to see how sensitive and how careful you have to be. So this is what this sounds like. Okay, and I think we should take maybe 30 seconds here just to just for the young players out there, just to explain what exactly we're doing here, and what parametric EQ is. This demonstration is perfect because I'm looking at the manual here for the Mackie 32.8 bus, which is the board that we're using here. And here is 3 graphs representing the parametric EQ for the midsection. You got to be really careful when you're looking at a board with parametric EQ. I'll show you why. Let's look at any of the channels. We've got the high, mid, we've got frequency, it's pretty straightforward, and then we've got bandwidth in octaves. And looking at this knob here, where are we? Bandwidth octaves. See 3, and then on this side you see 12. But you look really carefully, be very careful, because that's actually 3 and 1/12. 1/12. Okay, because up here, see, it's 2, so it's actually going down. So a 3 to 2 to 1, and then to all the way to a 1/12 of an octave. And it looks like 12 because the 1 actually looks like one of the little marker points on that curve, which is kind of a poor design. But you got to be very careful when you're looking at boards like that. You would assume that this is the tightest and this is the most broad curve, but it's actually the other way around. This is the most broad, which represents this curve right here. And then as you turn the knob up, it gets tighter. That makes sense. I have to think about that for a second. But anyways, yeah, here we are. So this is the tighter, because that's 1/12 going down to 2 octaves. 1 would be around here, and then all the way to 3. So let's see what this does here. So right now, channel 27, this is all straight ahead. Okay, here's our 1 kilohertz signal. And let's try boosting this first. Okay, so we got an octave of 2 octaves right away, just not even doing anything, that boosted the signal. Let's try and cut it. Or sorry, let's try and cut that, because it's annoying listening to that. Okay, so I'm trying to cut it. So going down, turning this knob down to 1 kilohertz. Let's hear listen to what happens. So it definitely got quieter. let's turn up the, let's make the bandwidth a bit tighter. As I'm turning that, I can see that there's a spot there, definitely a spot there where it sucks out that 1 kilo. Let's make the bandwidth super tight. And you can see that there is a spot there where turning it up, turning it down. I'm sweeping the frequency right now. So yeah, you can tell there is this little spot there where where it will actually take out that frequency. Now it doesn't completely take it out. So that's something to note. It doesn't completely take it out. And also note where the position of this knob is not exactly 1 kilohertz either. Let's try this again. Let's see. Let's check our frequency counter. Still 1 kilohertz. Let's try that again. This should be able to suck that right out. So that's about as best as I could cut that frequency out. This does have a low mid section. Let's see if we can. So that's almost completely gone when we use the other part of the EQ, which is the low mid. Let's turn this back up for a sec. How sensitive is this knob? First of all, where it says 1K is obviously not 1K. That's where it's cutting the frequency, but it's not exactly at 1K. It should be, because we're 1K right here. Okay. So you can see how much I'm turning this knob here. And it's very, very sensitive. So not only is it very sensitive, but it's not at 1K. And neither is the low mid. Really. Okay, 350. Who knows where 1K is here, right? Not like a linear scale. We have to use our ears. So these are very, very sensitive. So when you're doing, I think the moral of the story here is when you're doing EQ by ear, you got to be really careful where you're putting these knobs. And you know, movement of a slight millimeter here or there can make all the difference if you're really trying to pinpoint frequencies. And I guess the moral of the story is this whole thing where you're like, well, we'll fix it in the mix. It's not always the best option, because it's pretty hard to do that. You have to be pretty skilled. Ears have to be pretty sharp to hear that. And this is with a very clean tone. So I hope that was interesting. I don't know what I'm trying to prove with this, but I just find that this little experiment pretty interesting, and I hope you found it interesting as well. Yeah, thanks.